Solving quadratics by factoring. First, we're going to start out by reviewing the zero product property from Algebra 1. Anything times 0 is equal to 0. So in this case, if we let A equal 0, it doesn't matter what B is, our product will be 0. If we let B equal 0, it doesn't matter what A is, our product will be 0. So we will be using the zero product property as we solve quadratic equations by factoring. So we have some basic rules over here, steps for you to follow. First thing, does the equation equal 0? So let's take a look at what we're given. Yes, it is equal to 0. Well, if it did not equal to 0, we would definitely have to make it equal to 0 by moving all the terms to one side of the equation. We can definitely skip this step. Next, it says to simplify. We would combine any like terms. We don't have any like terms, so we're going to move to step 4, the gist of our lesson, factor completely. So let's factor 3x squared plus 18x. Well, we pulled out a GCF because we know 3x squared and 18x have a common factor. We pull out 3x and we have x plus 6. We have factored completely. Next, step 5. You got it. We are going to set each factor equal to 0 and then we will solve. Our first factor is 3x. We let 3x equal to 0. Our next factor is x plus 6 and we let x plus 6 equal to 0. What is next, you think? All right, and as we set each one equal to 0, we get that x is equal to 0, and over here, x is equal to negative 6. We put these in our little curly brackets to represent the set that will solve this quadratic, which is 0 and negative 6. Here we have example number 2. Does the equation equal 0? Oh my, it equals 10. What are we going to do? We are going to move all the terms to one side of the equation. We will do this by using our inverse properties. So using our inverse property, we subtract 10 on each side, and we don't have any like terms with negative 10, so we're just going to have to write it here. And we have 3x squared that we brought down, 13x that we brought down, and negative 10 is equal to 0. What do you think is next, now that we have our quadratic equal to 0? Next on our list is to factor completely. So let's get ready to factor this. We are going to put it in factored form. Here we have it in factored form. 3x squared. The factors of 3x squared are 3x and x. We need the factors of negative 10. Let's see what that is. So for our factors of 10, we could try 10 and 1 or 5 and 2. Let me put a 5 here and a 2 here. Don't forget our loops. These two multiply to 2x. This multiplies to 15x. 2x and 15x. How could we get 13x? We'll go ahead and subtract 2x, and we'll have 3x minus 2 and x plus 5. And of course, now that we have it factored, we are going to set each one of the factors equal to 0. So here we go. 3x minus 2 is one of the factors. We set it equal to 0. And x plus 5 is the other factor, and we set it equal to 0. We add 2 on each side, and we get 3x is equal to 2. We divide by 3, and x is equal to 2/3. Over here, one step, subtracting 5 on each side, and x is equal to negative 5. So my solution set, put it in my little curly brackets, will be negative 5 and 2/3. Example number 3. First thing we ask ourselves, does the equation equal 0? In this case, it doesn't. So what we're going to have to do is use our inverse operations to set it equal to 0. That gives us x squared minus 6x minus 27 is equal to 0. Let's go ahead and get us our factored form together and let's see what we get. We're definitely going to put x as our leading coefficient in each of our set of parentheses. And now let's look at the factors of 27. Factors of 27, 9 and 3. We could check with our loops. This will give me negative 9x, and this one would give me 3x, and together that will give me negative 6x. So exactly what I want. Checking our work as we go along. We're at the point where we can set each factor equal to 0. So that's x minus 9 is equal to 0. And over here, x plus 3 is equal to 0. We'll add 9 to both sides and find out that x is equal to 9. We'll subtract 3 from each side and find out that x is equal to negative 3. So these are my solutions. I'll write them and put them in my curly brackets to show the set that satisfies the equation. And here are some practice problems for you to try. 1 through 5. Let's take a look at those. You're basically going to go through the steps, making sure they're equal to 0. You're going to move the terms to the other side if they don't. And once you get it set equal to 0, you're definitely going to factor and solve. Pause right here, try the problems, and then I'll show you the answers in the next couple of seconds. And voila, here are the answers to the ones that you tried. Were you able to try number 6? Well, I gave you the solutions and I wanted you to get back to the quadratic. Well, if you didn't know how to do it, no worries. We're about to go over an example right now. So if you are given the zeros or the roots or the solutions like you are in this problem right here, what we're going to do is we're going to work this basically backwards. We're going to start with the solutions and we're going to write out the equation in standard form. So here we go. We start off by adding 2 to each side. When we do that, we have 0, and on this side we have x plus 2. Interesting that when we first started, we had to get everything on one side and let 0 be on the opposite side. Now we're working backwards. We're going to make sure 0 is on the side by itself. So in that case over here, we're subtracting 3 on each side, and this becomes x minus 3 is equal to 0. Well, now we have our factors. Here we're going to put x plus 2, and here we're going to put x minus 3, 0 product property. One of these is 0, would make the whole thing 0. Well, where do we go from here? Well, let's FOIL this out, multiply it out, use a distributive property, box method, whatever you would like to call it. It's time to do that.